Good morning. Welcome to today's webcast, Invaluable Insights to Optimize the Performance of Separator Systems. I'm Mike Rhodes, Managing Editor of Hydrocarbon Processing Magazine, and I am your moderator today. For more than 60 years, Tracerco has provided invaluable insights to enable operators to make informed decisions. Its specialist inspection techniques, sophisticated tracers, and advanced measurement technologies can accurately and rapidly diagnose a wide range of production issues and problems. Tracerco Diagnostics services can be provided at the hydrocarbon recovery and separation stages of production. These services enable you to optimize the performance of separator systems by measuring online and in real time what is occurring within your offshore assets. In this webinar, we will discuss how Tracerco's field-proven technologies can provide immediate real-time measurement of any changing process conditions. By identifying issues such as mechanical damage, leaks, deposit buildup, maldistribution, oil and water, and liquid carryover, shutdowns can be planned much more efficiently, whilst minimizing lost time and associated costs. Joining us for today's webcast event is William Bill Rivers, Commercial Manager, North America from Tracerco. With more than 20 years of extensive oil and gas industry experience, William Rivers has undertaken roles that build on his technical, commercial, and business development skill set. Completion of his MBA encouraged his exposure and understanding of all areas of business. Having been with Tracerco for 4 years, his current role sees him responsible for accelerating revenue growth and securing new partnerships for Tracerco in North America. As a highly motivated individual with the ability to converse with key stakeholders, he is the host of Tracerco's podcast series, Tracerco Talks. Launched in 2021, the podcast series takes a deep dive approach into Tracerco's technologies and how they have benefited many operators around the world. Okay, just some general housekeeping notes before we get started. Following the presentation, we will have a short question and answer session. You can participate in the Q&A session by asking questions at any time during the presentation. Just type your question into the Q&A box located on the bottom left corner of your screen, then click the Submit button. Please take this time to familiarize yourself with the webinar platform. At the bottom of your screen, there are multiple application widgets you can use. All the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. You may enlarge the slide window at any time by clicking on the arrows on the top right corner of the slide area. The slides will advance automatically throughout the event. If you are experiencing problems with the program, please press the F5 on your keyboard to refresh the presentation. You can also visit the webcast help guide by clicking on the Help button below the slide window. All right, we're ready to get started. And I'll turn the time over to Bill.
Good morning and good afternoon, ladies and gentlemen. My name is William Rivers. I'm the new Markets Manager for Tracerco, and welcome to today's webinar. Today, we're going to be taking a close look at some of Tracerco's techniques that can be utilized to help optimize and actually solve some of your offshore process problems. During today's presentation, we'll be discussing common process issues, as well as the techniques Tracerco uses on a daily basis to help solve customers' problems and issues. We have a special guest today, Mr. Wally Georgie. Wally has over 4 decades of experience in the oil and gas industry in the operations, processing, separation, fluid handling, and system integrity. Wally is a hands-on troubleshooting, we'll just call it a guru for argument's sake. He has worked all over the world. He's worked in the United States. He's worked in the UK and different parts of Europe. So we're very excited to have Wally today participating in this webinar. Wally, how are you doing today?
I'm fine, thank you, Bill. Thanks for the introduction. So the principles of processing oil and gas is that we have to have a reliable separators and scrubbers that will provide us the separation and the oil quality, the water quality, and the gas quality. However, we don't get it very often right. For a number of reasons, we don't get the design of the separators or the scrubbers correctly, or we over-design them or under-design them. And very often, sometimes, we have mechanical damage to the internals that can give us some poor performance of these vessels. In addition, we're depending heavily on chemicals for separation and treatment of the processed oil and gas. And therefore, sometimes we don't get the chemical treatment right. Under all these circumstances, we have issues with poor water quality, poor oil quality, carryover of liquid with the gas phase, and wrong measurements of liquid. All these things have an impact on the performance of the plant and, of course, the delivery of the final product into the refinery. There are a number of ways of doing the assessment. One of them is to shut down the system and go inside the vessel and determine what the cause of the problem. But the most cost-effective way of doing it is to do process diagnostics. Process diagnostics comes in different ways. You could map the vessel. You could use techniques like Newton backscatter, which Tracerco provides, or gamma scan, or tracer injection, or pipe scan. All those combinations of these techniques, depending on the level of the problem and the anomalies in the system, can be used to identify whether we have problems with the vessel internals, we have problem with the mechanical part of the internals, i.e. damaged internals, we have problem with the instrumentation, we have problem with the chemicals. All those things can be identified by using some of these techniques, whether Newton backscatter, gamma scan, tracer injection, and also pipe scan. Pipe scan can be very useful to determine the level and the type of carryover out of the separators. Because of the way we scan the pipes, we could determine whether the scanning is the carryover is bulk liquid or fine droplets of liquid. So we're going to go through some of these issues, at the moment with the next slides. So when we come to gas treatment and conditioning, whether it is involved gas retaining facilities, gas dehydration facilities, or gas drying or separation, there are a number of issues that can impact the performance of the plant, not to meet the gas treating performance plant or the CO2 or the dehydration capabilities. And that could be due to internals, or could be some slugging, overloading, or recycling. And it will be very difficult to actually do any CFD and give you an accurate root cause of the problem. But if we utilize the capabilities we have in Tracerco, for example, tracer injection and pipe scan, as well as the gamma scan, we'll be able to determine exactly the root cause of the problem, especially when we use the tracer injection. And we could use the tracer injection relevant to the different phases. We could use gas tracer injection, we could use oil tracer injection, the organic tracer, or we could use aqueous tracer injection. All these tracers, when we utilize them in the system, will be able to give us exactly what's happening within the vessels, whether it's caused by bad distribution, bad internals, or bad design altogether. So we have quite good capabilities to do that. And one of the key things also with gas treatment is the gas carryover in the vessels. Very difficult to pick up gas carryover in conventional means. So using pipe scan, we'll be able to determine the type of carryover taking place in the pipe out of the vessels. Whether it's a bulk, we could determine whether it's a bulk carryover, whether it's a missed carryover. All these things can help us to determine the nature of the root cause and how to fix it. When we come to produced water issues, there are different aspects of produced water that need to be addressed. If you have poor water quality coming out of the separators, the poor quality can be due to, again, the usage of chemical, the wrong use of chemical, excessive amount of usage of chemicals, internal design, or damaged internals. But also, bad water quality can be influenced by flow pattern, as well as the solid accumulation in the system. So And of course, there is poor water quality in the primary separation, which is the separators, or there's poor water quality coming out of the secondary and the tertiary stages of the treatment. And in all these cases, gamma scan, neutron backscatter, and tracer injection can be used to identify those factors, those elements. Of course, very often we start with the simplest process diagnostic, and if required, we go to the next stage and the next stage. When it comes to actually identifying the characteristic of the water, there is, of course, understanding the droplet size of the water throughout the process, and if there's any impact of solids accumulation or solid carryover with the liquid. And this will be used by using conventional techniques available to the industry for measuring the oil droplet size or the solid distribution of quantifying the amount of solids is in the system. So overall, when we have issues with produced water, the combination of understanding the issues in the separators, which is the primary water treatment side of the primary treatment stage of the water treatment, and combining the understanding of the performance and the droplet size distribution in the water and the second stage and the third stage, we'll be able to understand exactly whether the root cause is in the systems upstream the produced water system or within the produced water system. And by doing this, then we could focus on how to address it and how to resolve these problems. But there are a number of issues that can influence produced water quality. So you have the operational issues, you have the hardware issues, and you have the chemical issues, and you have also the common practice they do in the plant. By doing this process diagnostic, by looking at all aspects of the separators behavior, the produced water treatment, the produced water quality and characteristic, we'll be able to actually understand where the problems are and how we're going to fix it, whether it's upstream or downstream or within the produced water system.
Thank you, Wally. Now, let's explore Tracerco's first technique, gamma scanning. Gamma scanning utilizes a source and detector to create a density profile. And based on this profile, we can determine what's going on inside of your process equipment. Please keep in mind that when doing a gamma scan or any one of our techniques, this is a real-time measurement. No need for shutting down the process equipment or interfering with your normal operations day to day. This is an actual and real-time measurement while process equipment is operating. To follow up with what Wally said above, let's take a look at the different techniques used to diagnose process issues offshore. The first is the gamma scanning technique. As you can see by this example, if you look on the left-hand side is a radiation source, on the right is a detector. We start at the top and move our way down. We are creating a density profile. In this case, we were looking for the liquid bulk level inside of this separator. Another technique that Wally described was scanning for internals to see if they're in place. In this example, radiation source being on the left, detector being on the right, we scan from top to bottom, looking for a density step change. In this case, the density profile on your right shows that the demister is in place. Now, in the second example, let's explore what the profile looks like when the demister is not in place. Again, scanning top to bottom, you can see over on the right-hand side in the purple that there is no profile, which indicates that the demister is not in place. Please keep in mind that you can use the same technique to determine if your baffles are in place or if your mixing box is in place as well. Another type of technique that can be utilized is called a neutron backscatter. This technique is used when you wish to identify the different types of layers inside of your separator. Starting at the top and working your way down to the bottom, we can see based on the density profile that there are 5 different types of layers: a vapor layer, a foam layer, an oil layer, an emulsion layer, and finally a water layer. The last major technique we can utilize for separation process issues is a tracer study. A tracer study reveals residence time as well as carryover and carry under. On each major inlet and outlet, a detector is placed. A pulse of radiation is released upstream of the separator, flowing through the first inlet detector through the separator and out of the major outlet devices within the separator. From this, you can gather the residence time, the carryover, the carry under, as well as oil velocity and water velocity. Now we'll begin to talk about scanning pipe on offshore facilities. A technique that we commonly use is called phase finder. This utilizes the neutron backscatter technology in order to find deposits inside of your pipe. The way this technique works is we take the neutron backscatter device, place it on the pipe, and slowly walk along the pipe looking, again, for density changes. As we find the density changes or deposits in there, we will mark on your pipe where these deposits lie. If you'd like to look in more detail of what deposit growth is, or the size of your deposits inside of your pipe, we can perform a through-pipe scan. A through-pipe scan is a radiation source and detector attached to a yoke. We take this yoke and we walk down your pipe. As we identify a density change, we rotate it 90 degrees and back it up, and then walk forward again, scanning the same area. This will give a better representation of how high or how large your deposits are inside of the pipe. The last type of scan we can use on pipe is called a through vision. A through vision scan is the most highly detailed scan in Tracerco's arsenal. The way it works is we take a source and detector and place it 180 degrees apart on your pipe and rotate it into 9 different positions. From those positions, we can extrapolate over 1,000 points of data. And from that, we translate it into a color-coded map of your pipe, as seen on the left-hand side of your screen. Anything in red is considered highly dense material. Anything in blue is considered less dense material. In order for this scan to be most effective, it needs to be performed on a minimum of a 12-inch piece of pipe. Typically, we do these scans on flare lines that have not been cleaned out in some time. Let's move on to another area that Tracerco scans quite often: storage tanks and vessels. As in the separator study, phase finder, utilizing neutron backscatter technology, can help identify the different types of layers inside of your vertical tanks. As in the example, starting from top to bottom, you can see there's a vapor layer, an oil layer, an emulsion layer, a water layer, and a solid layer. This is a very efficient and easy way for you to scan quickly and tell what's inside of your tank. For our final technique, we'll be discussing flow rate measurements and the benefit it can offer you in offshore environments. Similar to a tracer study in a separator, flow rate measurements is used primarily to verify instrumentation is working correctly. A pulse of radiation is released upstream, travels past 2 detectors. From there, it's a simple calculation of distance over time to verify the instruments are working correctly. Again, this is primarily used to verify instrumentation is working correctly. Let's now look at a few case studies to demonstrate the value of the technologies discussed above. In our first case study, one of our major operating partners approached us and expressed concern that they were having carryover problems in one of their major vessels and asked us to perform a gamma scan to verify that all the internals were in place. Upon further conversation with the customer, they believed the demister was damaged in their vertical vessel. Based on the drawings provided to Tracerco, the gamma scan was performed in the area where the demister pad should have been. Starting at the top of the vessel and working our way down, we took multiple scans and quickly noticed that in the area where the demister pad should have been, there was a density shift to the right, indicating that the demister pad was no longer present. As we move down the vessel towards the bottom, the density dramatically shifts to the left, indicating the presence of collapsed demister pieces. As you can see in the scan example on the right of the slide, you will notice a long snake-like curve starting at the top and curving its way down to the bottom. If the demister was present, the scan's line would have been more tight and in a vertical straight line. As you can see on the left side of the picture is what a demister should look like when it's in place. And on the right, the damaged demister, which was confirmed by Tracerco Gamma Scan. In our second case study, Tracerco was helping our customer determine how large the emulsion was inside of their separator. Neutrons were selected as a technique to determine the size. We started at the top of the separator and worked our way down the side. As you can see in the graphic, there is a vapor space, which is represented at elevation 920 to elevation 830 by the blue line starting at the left of the graphic and running straight diagonally to the right. From this point, the oil layer is measured. In this case, the oil layer is from elevation 830 to 710. Further down the scan, you can see a sharp density shift from elevation 710 to 110. This is our emulsion layer. As you can clearly see, there is no water layer present. The water is mixing inside the emulsion. Upon the customer receiving the news of our results, we suggested that the use of a demulsifier chemical was needed in order to restore balance to the separator. After the emulsifier chemical was added, you can see the separator process improvement, as now the water layer is clearly present at elevation 350 to 110. There's only a slight emulsion layer from elevation 410 to 350. By painting a clear density picture of the customer separator, they were able to take action quickly and solve their problem. For our third case study, one of our major customers was having problems with their plant not reaching design capacity. After further investigation, they found and narrowed the problem down to 2 separators. Tracerco recommended a tracer study to determine which separator was causing the issue. A dose of radiation tracer was injected upstream of the separator. Traveling towards the first detector in red, we can confirm that the radiation has passed through and registered a confirmation pulse. The tracer enters the separator and immediately registers a stronger, wider pulse on the outlet side of the separator as depicted in green. The yellow detector confirms that there is no outside radiation interference and all results are accurate. In conclusion, separator B was having significant carryover issues, causing the plant not to reach design capacity. The root cause of the carryover in separator B was due to internal damage. As you can see in the graph below, due to the carryover issues, other significant problems were occurring throughout the plant. After the separator was repaired, the customer asked us to repeat the test. The results were no carryover was present, and the plant went back to operating normally. I'd like to thank everyone today for attending this webinar, and I hope you found it incredibly informative. I'd like to especially thank Wally Georgie of Maxim Oil for his contributions to this presentation. At this time, we'll be having a question and answer session, where you can ask questions to Wally and myself, as well as Tracerco personnel, about any of the techniques you've seen today.
Okay, we will now transition to the question and answer portion of our webcast. For our audience, you can continue to submit your questions in the Q&A box located on the bottom left corner of your screen. Also joining us now for the Q&A, we have Andrew Bouton, Senior Operations Manager, North America, and Wally Georgie, Principal Consultant, Operation, Oil and Gas Separation, Produced Water Handling and Flow Assurance from Max Oil Solutions. All right, we're ready to go. We've got some questions lined up here. Let's get started. How can you inject tracer to determine potential anomalies in the main separator vessel?
Andy, do you want me to answer this question?
Yeah, go ahead, Wally.
Yeah. So whenever there are potential issues with separator carryover, there is a number of ways to handle it by using tracer injection. Depending on the issues, we could use
oil-based tracer, water-based tracer, and we use also gas-based tracer. We can inject all these tracers individually upstream of the separator that has the problem in the anomalies. And we could do two things. We could either simply look at the carryover issues from the outlets, the individual outlets, and we could determine the behavior. We could see whether there is a sort of recycling in the separators. We could see if there's a liquid carryover in the gas phase, and we could see if there's a short circuiting in the process. But we could go beyond that. We could do flow pattern, flow behavior within the vessel by putting detectors within the body of the separators, and we could see how the separator, the flow rate in the separator and the flow regime is, and we could determine if there is any potential blockages, solid accumulation, and internal damage. So tracer injection can be very effective in doing basically understanding the carryover issues, damages in the separators, and as well as solid accumulation in the separators.
Okay. Another question here. Where can you use neutron backscattering in the process system?
Neutron backscattering is a very useful tool, and it's very simple technique to use. We could use it in most separators, whether it's a horizontal separator or vertical separators. It's more effective in horizontal separators. The main question is the wall thickness. The neutron backscatter is based on a very low energy source and can have limitation if they have a very thick wall separator or very thick wall vessels. But can pick up, as Bill showed you in the presentation, that we could pick up solid accumulation, anomalies in the interface, and bad emulsion, as well as we could pick up the foam. So it could be used in separators, and the result can we get very quickly. Where we have problems with neutron backscatter, if there is installation around the separators, or what we call lagging or installation. Sometimes there's a water buildup between the separated vessel and the installation, and the water can give misleading data. But generally, we could get some good information by doing neutron backscatter and understanding the potential solid accumulation, bad emulsion, and also foam in the separators.
Okay, here's a question about diagnostic capabilities. How can you use diagnostic capabilities to determine and fix produced water problems?
So I will answer this question. So when it comes to produced water problems, is like I said in the presentation, first we need to identify if the issue with produced water is in the primary phase of the treatment, which is we consider all the time the separation is the primary phase of the produced water treatment. And by doing process diagnostic, whether we're doing it with the neutron backscatter, whether we do it with a gamma scan or even tracer, we'll be able to determine if the root cause of the produced water problem is in the separator themselves or further downstream. If they are further downstream, we could use produced water characterization tools, where we be able to put online equipment, where we be able to measure the droplet size distribution, as well as we can see solid accumulation and the type of solids in the system. So it's a combination of using radioactive tracer material, source material, as well as produced water characterization tools. We could determine then where the issues are, whether the issues are in the separator or downstream. It's caused by chemicals. We could see that because identify the droplet size distribution and there's a solid accumulation. So the combination of the radioactive sources as well as the water characterization tools can be used effectively to determine the issues and how to fix it.
Okay. Are the same diagnostic techniques, how do they differ when determining gas carry under? That's another question from our audience.
Well, that's very simple. So we could actually, if there is a suspicion there is a gas carry under, one of the key things we could do is when we inject radioactive tracers, it's very effective when you inject radioactive tracers, gas tracers. We could pick up a number of things. One of them, we could determine the gas carrier under, because if we're going to have gas carrier under, the gas tracer will go with the oil. But also, depending on the type of internal configuration, very often we could see with gas carrier, with gas anomalies, is how there is a recycling of the gas phase within the separator, especially sometimes with specific internals, inlet devices. So using gas tracers, we could determine the gas carrier under very easy. But also we could do it by determining the changes in the density, because if we have gas carrier unders, the density is going to be lower in the oil outlet than without gas carrier under. So we could actually do pipe scan, and we can determine the gas carrier under from pipe scan as well as using tracers.
Okay. We have some more questions here, and for our audience, you can continue to submit your questions in the Q&A box located on the bottom left corner of your screen. Here's another question for you. If there is insulation or cladding on the separator, does this impact the testing? Does the insulation or cladding need to be removed?
So this is a good question. I already actually mentioned it. So the cladding themselves or the insulation themselves will not impact the measurement. However, very often there are some old claddings and insulations where there is a buildup of dampness between the wall of the vessel and the insulation, and there's a buildup of water. So when we do the neutron backscatter, the neutron backscatter is going to pick up the water accumulation rather than what's going inside the vessel, and would interfere with the reading. So yeah, if we suspect there is water accumulation between the separated vessel, the external vessel, and the cladding, then we have to remove some cladding, and we could build up a scan of 3 or 4 lines within the vessel, and we have to remove it through that part of the vessel. But if there is no accumulation of water, we could do this. We could do the neutron backscatter without removing the cladding.
Okay, another question here for you. In a tank application, can you detect, for example, a solids accumulation or solids mound in the middle of the tank?
Okay, I'll take that one, Wally.
Yeah.
So with the neutron backscatter, the neutron backscatter only penetrates a certain distance into the vessel, approximately 12 inches. So if you've got a very large tank, then accumulation in the center of the tank is not possible to measure. In the instance of it's being submerged under liquid, I'm assuming there. If the mound of material is outside of the liquid, then we could move over to a gamma scan, and that would be able to pick up the solids there. But solids inside of a liquid on a tank is only, at the wall measurement.
Just to add to this,
okay.
If we have if you suspect solids in the tanks, sometimes you could do sort of a combination of different techniques for identifying the solid in the tanks, and it's being done in some projects we work together where you could use a tracer, and the tracer will show circuiting because of the solids. So sometimes you have to do a combination of 2-3 different techniques to build up the full picture of the solid accumulation if solid is suspected to be an issue.
Okay. Any process impact from the tracer injection?
The tracers we select, the tracers we select for any particular process stream, we analyze the process stream and we make it's a compatible tracer. So obviously in water systems we use an aqueous-based tracer. In organic systems we're using an organic tracer there. The amount of tracer we're putting in, it's radioactive, but it's only a few grams of material. So we do the analysis, we'll provide any SDS sheets to the customers, but in most instances there's very little impact to the actual process itself due to the quantities of material that we're using now.
But also it has a very short life, so it doesn't have a long-term effect on the environment and safety as well.
Many of the tracers we use have a radioactive half-life in the matter of hours, so they're decaying away very fast, and any impact of having the radioactive material there decays away in just a matter of days.
Okay. Another question for you guys. What are the limitations of neutron backscatter surveys on separators?
Do you want to answer that, Andy, or do you want me to answer it?
Yeah, you can start, Wellington.
Yeah, actually, I already said that the limitations are the wall thickness can be a limitation. Heavy, high-pressure vessels with the thick walls thickness can be a limit to the technique, and also the issues with the water building up between the vessel wall and the cladding. Otherwise, there are no limitations. It has a very flexible and robust way of measuring it. Measuring the inside of the vessel, whether we have liquid, foam, bad interface, or solid. But the limitation is the wall thickness and the cladding, water buildup between the cladding and the wall of the vessel.
Okay, another question from our audience. What factors constrain your ability to apply a particular technique?
Andy, do you want to answer it?
Yeah. So we try to pride ourselves in being adaptable for all customers' needs. So we would assess, the problems that the customer's having, and we try to, sometimes a sealed source gamma scans, neutron backscatters will provide all the information that's needed, but sometimes going that extra step, doing the tracer work, doing a distribution or residence time gives added information to the customer and brings it there. But there's no one definitive answer of a limitation to one technique on any particular vessel. So we try to cover everything that we can with the different techniques.
Technique-wise, there are no limitations, but application-wise and practical-wise, there are sometimes challenges. For example, location of the vessel, the pipework you want to scan, which requires some kind of scaffolding, so that can add to the process of doing the job. But generally speaking, the techniques themselves are very flexible in applying them in any kind of circumstances. But the challenges of applying it in the system and the logistics of doing it, and of course sometimes the regulations of handling radioactive sources in certain countries can be a challenge. But otherwise, it's been widely used. The process diagnostics in the North Sea, been used offshore Brazil, as well as been used in the Gulf of Mexico. So it's been easily applied in different locations and geographical places.
Well, you guys did a good job answering what was a pretty broad question, so well done. Let's go for another question here. Which method will you recommend if there is particle carryover, either on the oil phase or the water phase?
So this is a tricky question. So whenever there's particles, if we have particles in the system, it has some kind of a knock-on effect on the process. So if you have particles in the system, that means you have solid accumulation, especially when you have sand. If you have sand, you're going to have solid accumulation before you start seeing the particle carry over in the oil system. So doing neutron backscatter can be a good tool for understanding the sand accumulation, because when we talk about particles here in the oil, we talk really primary solids. Solids, I mean sand, unless of course there are some scale issues. So a combination of understanding the issues, we could do neutron backscatter. Now it could tell us how much sand is building up in the system, which would have a knock-on effect on the carryover in the sand phase, in the oil phase, I mean. Water phase, again, we could do neutron backscatter, but also we could do water characterization of taking water samples online, and we could determine how much solid is there. Whenever it comes to solid particles, solid counting, we have to do sometimes filtration as well. But so it's a combination of neutron backscatter, produce water characterization, as well as sampling and analyzing the solid that we could collect, because we could do filtration under pressure, and then we could do analysis of the solids that is we collect from these streams. And of course, if it's really bad, we could do we could do tracer injection, because the tracer injection is going to give us indication if there is any short circuiting, because if there is solid buildup in the system, there will be short circuiting in the system, and that we can pick it up from tracer injection. So there's a combination of different things you could do.
Okay, another question from our audience. Can we do gamma scanning on vacuum columns and ejector systems?
Andy, I leave that to you.
So vacuum towers, distillation towers, all of them you can do a gamma scan on. There are some limitations. So vacuum towers can generally be very large diameter towers. So there is some limitations on the diameter of the towers. We have done some up to maybe 35, 40 feet in diameter, but a lot of it, in principle it can all be done, but we need to use a radioactive source to do the scans, and in some parts of the world we are limited to how big a radioactive source we can use to do certain vessels. So there are limitations, but in general, we do vacuum towers quite regular. So that's definitely something that's in our portfolio.
Okay. Excuse me. Here's another question. For the application that was shown on the slides where the tracer went about 5 different ways, does that work with one single type of tracer molecule, or do you need to dose a bouquet of tracer molecule types with different mixing probabilities for each phase? That's quite a long question. Would you like me to read it again?
No, I got it.
Yeah, you answered, Andy.
Okay.
Yeah. You want me to go? Yeah. So with the radioactive tracers, with the radioactive tracers, we have a lot of options where we can trace, again, like the organic phase, the aqueous phase, the gas phase. In each of these, we use different radioactive materials. So if we're tracking the gas phase, the vapor phase, then we would inject. Typically, it's a krypton gas or an argon gas used in them, so we would have that irradiated to do the injections. With organic tracers, it's generally some sort of bromine compound that we use in there, and then for aqueous, it's generally a sodium compound. So we have a whole host of different tracers that we use, and we would use them for the different phases through the vessel, so we know we faithfully track that particular phase through the vessel itself.
So the purpose of injecting the individual tracers is to give us an idea about potential carryover as well as distribution and flow regime. So for example, the benefit of injecting gas tracers is to see how much of the gas is actually going with the liquid phase, so we know there is gas carryover. The same thing if we inject the water-based tracer. When we inject it, we will see how much coming out with the oil and how much going out, of course, in the water, and how much possibly going out in the gas phase. That will give us potential separation issues if there is too much of it going with the oil phase. And the same thing with the oil phase, with the oil tracer, the organic tracer. When we inject it in the system, we will see how much of the tracer coming out with the water phase, or how much of it going out with the gas phase. So we know how much carryover is going with the system. So every tracer which is injected individually will be able to tell us, whether there is a carryover, there is a good separation, bad separation, or any other potential anomalies in the system. So the tracer injection is very useful to give us all this information individually.
Okay. Is there an effective minimum density difference requirement between water and a heavy oil to get a good reading?
Do you want to answer that, Andy, or to answer it?
I'm assuming this question's in relation to neutron backscatter and identifying an interface between the water and the oil. So the way neutron backscatter works, it doesn't actually measure the density. It's the hydrogen concentrations of the two materials that we're looking at there. So yeah, we've done checked interfaces on very dense oils. We do it on sometimes in chemical plants on two materials that have close densities as well. So it's not actually the density we're measuring with neutron backscatter, it's the hydrogen concentration. So it is possible to get, very close densities together and be able to measure the interfaces.
Okay, another question. How is entrainment quantified? So is it part per millions in one phase versus another? When you're using radioactive tracers, what's the expected accuracy?
Do you want to answer this, or do you want me to answer it, Andy?
You can go, Wally.
So whenever we have, of course, the tracer injection and the analysis of the tracer injection has a software. And what we do is we take into consideration the area under the peak, and also the behavior of the peak, as well as the time of the peak coming out from the point of injection to the point of the outlet. So using the information and the software available, the peak, the area under the peaks, the shape of the peak, and the time of the peak coming out, we'll be able to determine, whether we have good separation or bad separation. We have anomalies in the system, blockages, short circuiting, and of course we know theoretically what is the residence time of the oil and the water phase in these vessels, and we compare it with the different time factors we have from the peaks. That will all tell us, by taking all this data together, we'll be able to tell exactly what's going on inside the separator, whether we have internal damage of internals, salt accumulation, or the separator have a proper plug flow. So there is the combination of the size of the peak, the area under the peak, and the time it takes for the tracer to come out of the system. Because if you have a good separator, let's say hypothetically, the tracer should go in and out within, say, 15 minutes. But if you have bad separation or other anomalies, the peak can extend for over an hour and a half. That means it tells you that there is a bad mixing within the vessel itself. So we do this and really sometimes can give us a very good indication of the nature of the vessel internals and the behavior, whether we are injecting water phase tracer, oil phase tracer, or gas phase tracer. They all give us very valuable information when we do the analysis using the software provided with the injection of the tracers.
Okay, we had a previous question that talked about the gamma scanning on vacuum columns and ejector systems, and as a follow-up kind of clarification, can this detect leaks in the vacuum system?
Okay. We can detect leaks in vacuum systems, yes. So we have a number of different techniques we do there. A gamma scan we wouldn't normally be using to find a leak in a vacuum system. I see some other questions there. So generally we use helium leak testing, looking for air ingress leaks in vacuum systems, if that's what the customer is requiring. So yeah, obviously if the system's under vacuum and you're getting that air sucked into the system, we use helium leak testing to go around, and we have a sample point and a mass spectrometer to analyze the process stream downstream. And then we would go around using helium to try and identify those air ingress leaks. With an offline system, we can pressurize up exchangers and look for a tube leak in a particular exchanger. So we can do that as well. Then even on vacuum systems, if you've got vacuum on an exchanger and you're looking for a leak from one side, process side, to the opposite side, you know what I mean? If they're both under vacuum, one's under pressure, one's under vacuum, we've done those types of leaks and heat exchangers as well. So these are all possible. So we would always ask to try and get some information on that particular system, and we would try and make a test suit the particular need of the customer at the time.
So Andy, you're talking about, you can read question 20 when it talks about identifying the leakage in the heat exchangers and closed loop system. Shell side is cooling water, low pressure, and tube side is hydrocarbon, high pressure. That's right in line with what you're talking about.
That is a very similar, yeah. Every exchanger, every system is slightly different pressures, different temperatures. So when we do a heat exchanger leak test, we can do them on closed loop systems. The material we inject on a exchanger leak test needs to be mixed with the high pressure side. So what we're trying to do there is that the tracer we inject would mix completely with the material in the high pressure side, and then when it leaks across to the low pressure side, we have two options. If we use a radioactive tracer, then we can detect that leak using external radiation detectors. But if the leak is very small, then sometimes what we would do, we inject a chemical tracer rather than a radioactive tracer, and then we actually take samples from the low pressure side, and we would again, be able to identify a leak, and given the flow rates through the system, we can estimate a size of leak for the customer as well. If you've got multiple exchangers, we can do either multiple injections or multiple detector sample locations and narrow it down to sometimes a single exchanger in a bank of, say, multiple exchangers. Again, these are very custom to the particular need, so whenever that instance comes around, we would reach out to the customer, try and find out, see what the process stream materials are, what the temperatures and pressures are, and again, we would select a particular tracer to meet that requirement.
Okay, I think we have time for a couple more questions here. We'll squeeze them in. What about separation efficiency and vertical separators? What are the factors that influence the selection between vertical and horizontal separators?
Do you want me to answer that, Andy?
Yeah.
So I'm not sure if I understand the question right, whether there's a decision to make a decision whether to design a vertical separator versus horizontal separator. That's not obviously the topic here. We are talking about process diagnostic, but we could. There are different ways of identifying issues in vertical separator versus horizontal separator, and generally speaking, we could use gamma scan to do identification of what's going on within the separator, whether it's vertical or horizontal. And also we could use tracer injection. We could use neutron backscatter, but sometimes the neutron backscatter within the vertical separator can be limited because of the area we are looking at. But certainly gamma scan and tracer injection can be very, very beneficial for identifying any anomalies in vertical separators. And we already spoke about the potentials where we could do these things also in horizontal separators. But very often we have scrubbers. When we have scrubbers, gas condensate scrubbers, which are generally vertical, we could do a lot of process diagnostic using tracer injection and gamma scan of these vessels. But also we could do pipe scan. We talked about pipe scan. Pipe scan is scanning the pipe at the inlet of the vessel and the outlet of the vessel, gas outlet of the vessel. We'll be able to tell the potential liquid distribution going into the vessel and how that impacts the process within the vessel. And we could see from the outlet pipe scan, we could tell if there is a carryover or a missed carryover or a intermittent carryover. All these things have an influence by what's going on inside the vessel. So we could do, when it comes to vertical vessels, especially gas scrubbers, the combination of gamma scan tracers as well as the pipe scan of the inlet and the outlet will be able to determine what's going on within the vessel and how to address it.
Okay. you may or may not be able to answer this. What is the maximum vessel wall thickness that can be used for neutron backscatter techniques?
As normal, there's no real firm, straight answer on this, but in practical terms, once you get above 2-inch wall thickness, then the neutron backscatter efficiency reduces. So it would be somewhere, it depends on a particular application, but somewhere between 2 inches and 3 inches is the maximum of being able to see a level or an interface in there.
Okay, let me squeeze in one last question here. How to deal with emulsion formation in case of heavy oil having density almost equal to water?
Okay. I guess that was similar to one of the other questions about neutron backscatter, in the fact that neutron backscatter it's not measuring the actual density of the two materials, it's looking for the hydrogen concentration of the two materials. So even in instances where you have a very heavy oil and a water you're trying to separate, it's somewhat harder to see, but it can still be seen. You see, the interface can still be seen in those particular instances, because we're not actually measuring density of that particular technique.
Okay, well, we want to thank our audience for your great questions, and thank you for attending today's webcast. A special thank you to Bill Rivers and Andrew Bouton and Wally Georgie for their great participation and the knowledge that they've shared with us. We want to extend a thank you to Tracerco for putting together this timely and informative presentation. Finally, an on-demand version of this webcast will be made available in the coming days and will be emailed to everyone. Again, thank you to our presenters and our panelists. Thank you to Tracerco, and thank you to our audience for joining us today. Hope everyone has a great day.